Welcome to our next lecture on the Python programming language. In the past, we have seen several aspects of the language, including its various data types, also how to write our own functions. In fact, right now on the screen, as you can see, I have already started the Python interpreter and I have invoked the mantra from turtle import star, which allows us to use the turtle module in its entirety. Then, as always, I'd reset the screen, set the width to 3 so that the drawing on the screen is thick so that you can see properly. And then I have defined the square function with 2 arguments. The first one, L, is a mandatory argument. You have to give this one. C, on the other hand, has a default value, black, so that even if you do not give the second argument, C will be assumed to be black. So what it does is first changes the color of the pen to the variable C, whatever the value of the variable C is. After that, this is the simple standard loop or drawing the square. So this loop runs 4 times, as you have seen many times before, and for each step the cursor moves forward to a length L and then turns right through 90 degrees. And I've just shown you what happens if you call this function square. In this case, I've called it with 2 arguments. The first one is the value of L. So L is 100. The second one is going to be the value of C, which is red. So that is why the turtle, as it moves, has drawn for me a red square of side 100. Okay. Can we do a lot of fun stuff with simple functions like these? Actually, we can. Let me show one example. And for that, let's reset the screen once again. Set the width back to 3. And then what I will do is I will draw not one square, but many squares. And for this, what I will do is, instead of using I as the variable, although I could have, I'm going to use L as the name of the variable over which the loop runs. And remember, we could call range with up to 3 arguments. And say I could call it like this. Steps. So this is create or return the numbers 100, 120, 140, etc. Do not touch 400, but go all the way up in steps of 20 until you just touch 400. So that's what the range function gives L. And so this means that the loop is going to run several times, and all I have done here in the body of the loop is asked you to plot this square with the side length L. So what this will do is start from the middle, draw a square of side 100, come back to the middle, draw a square of side 120, and go on. So let's see what happens here. So there's a 100 side square, 120 side square, 140, and so on. So see, a rather nice looking pattern is emerging out here. Of course, it's going to take quite a long time to draw this whole thing. In fact, that's not because the computer is slow or turtle is slow, it's because the turtle is deliberately kept slow so that you can see what happens in action. So this is the side 380 square that was just drawn, and that's where your loop has ended. Of course, you can see that the loop has ended because your command has come back. The prompt, the interpreter prompt has come back to you. Just to show you another nifty thing you can do with this. So let's go back here, and now what I will do is, instead of drawing squares of different sides, I'll draw many squares of the same side length but slightly tilted with respect to each other. So something like this. So range, let's say I'm going to draw 30 such squares, and then what do? I draw squares of side 100 each, but after I draw each square, I turn left to an angle which I find by demanding that by the time I end the loop, I have to have turned all the way around. So 360 degrees in all. So since I'm going to do the loop 30 times, the body of the loop is going to be executed 30 times. Each time I need to turn by an angle which is 360 by 30, that is 12 degrees. And see what happens if I do this. So one square, now you see the squares are turning around, and you're going to get a rather nice looking pattern on your screen. Of course, depending on your imagination and how skillful you are at this kind of art, you can think of drawing many different nice patterns just by using the simple function that we have defined. It does look rather nice in the end, right? There are more steps to come yet. It has to go all the way around, and you're done. So notice that there are so many close straight lines here that the whole thing is really looking like a circle inside. The inside line is looking like a circle. Now, speaking of circles, there is a function which will draw a circle for you in Turtle module. The function is actually called circle. And if I want to know what it does, what I will do is invoke a function which I should have talked to you about perhaps long ago. It's the help function. I don't remember whether we have already discussed this in some other video, but it's so important in the process of learning Python that it doesn't hurt to learn about it again. You want to learn about a particular thing that the interpreter can handle. The best way perhaps is to just use the help function. Here you are saying help circle, and this is the kind of output you get. The output doesn't look very nice here for the simple reason that I'm using too big a font. Now perhaps it will look better. So it says something like this. Circle, that's the name of the function. Then comes the list of arguments. The first argument is the radius, which of course is the radius of the circle that you want to draw. Extent equal to none. So extent has a default value of none. We saw this trick the last time around. And steps also the default value of none. What that means, of course, is that I can call the function circle with just one argument, which has to be given the radius. So arguments, here is very explicit. It says radius has to be a number. Extent is of course optional, has to be a number. Steps has to be an integer. Notice the difference between the three things. Radius and extent can also be fractional or floating point. So a number is either integer or a floating point. Steps on the other hand has to be an integer. So what does it do? The help also tells you exactly what it does. Draw a circle with a given radius. The center is radius units left of the turtle. So wherever your turtle is, the center is at a distance of that radius, whatever you have specified, to the left of your turtle. And extent is an angle, determines which part of the circle is drawn. It tells you how much of the circle you are going to draw. If extent is not given, of course if it's not given, then by default it's none. And the way the function is designed, when it's not given, it draws the entire circle. If extent is not a full circle, one end point of the arc is the current pen position. So, of course, if it's a full circle, then you go all the way around and come back to the current pen position, wherever the pen or the turtle is. If extent is not that of a full circle, it's going to start from where you are and draw an arc of that length. So the arc is drawn counterclockwise. All this information is here. One thing that you have to know is when you start something like this, you see what has happened is your prompt has gone away. It's now a single colon. This is A different kind of continuation prompt is saying that help has not stopped talking back to you. It's going to give you more and more information. You just use the arrow keys or the page down keys to go further down. You can of course also use the up arrow key to go up and reread something which you may have missed the first time around. This is sort of intuitively obvious. If you want to get out of the help, you have to hit Q. So that's how you get out. Okay. So now that we have learned something about the circle function, let's try to use it. And again, let me make the window slightly smaller so that you can see what's going on in the canvas out here. And just to unclutter the thing, let's reset the canvas, set width to 3, and let's have some fun with the circle function. First of all, let's just draw the circle. Draw a circle of say radius 100. Notice what the help told us was the current pen position is where the circle is going to start from, the turtle's location, in this case the center of the canvas, and the center will be, in this case, 100 units to the left, so it will be somewhere here. So remember, you are facing this way, so to the left means this way, center is somewhere here, 100 units, and so circle will be drawn counterclockwise, so it's going to go like this. So that's exactly what's going to happen. See, and you're back where you were. So this is what the circle is. In case you were wondering about what the steps, the third argument in circle could mean, let's just show you what it does. Say 10. What that means is that instead of trying to draw a smooth circle, it just draws 10 steps in drawing the circle, which means it ends up drawing a regular 10-sided polygon. This should make you realize that even drawing the square, the one thing that we had done, we had defined a square function, but we did not really need to. We could actually use the square function, the circle function, with steps equal to 4 to draw a square for us. But anyway, it's always good to learn how to write your own function, especially because it gives you more flexibility, as we will soon see how to exploit. But now that we have learned how to draw the circle and what its arguments are, let's try to quickly show you what kind of nice designs you can make with it. So, you have to realize that drawing circles and making nice designs is not the only aim here. I'm trying to show you how to use various Python constructs like loops to sort of exploit the capabilities of the turtle module better. So once again, let's reset and set the width back to 3. And then I will do one more thing. I will change the speed of the pen drawing to fast. So speed is a function which again turtle provides. It takes a single argument, which is a string, which tells you essentially how fast you want the drawing to be done. Fast is faster than normal. And the reason why I'm doing this is that I want to finish the drawing quickly, and I'm going to draw a rather lengthy thing here. So what I'm going to do is something like this. I'm going to first run a loop with the loop variable I, say 30 times. So I'm really drawing 30 circles of radius 100. Okay. So because I'm drawing it this 30 times, it's going to take some time, and that's why I put the speed too fast. But of course, if I just do 30 circles, every time coming back to where you are, these circles will be drawn on top of each other. So instead of doing that, let's just turn the circles, maybe right, to 12 degrees. Remember the idea that we had used? I want to go back where you were at the beginning. So 360 degrees in all. You're running the loop 30 times. 360 by 30, 12. And let's see what comes out. The speed fast doesn't really seem to be very fast, at least not to me right now. But there's another option called fastest, which will actually speed it up a lot more. But I'm pretty sure you will agree that it's rather satisfying to see this turtle crawl on the canvas and draw out a nice geometrical shape. And in the end, you end up drawing a pattern which you have seen perhaps many times in maybe posters. I find this pattern rather nice to look at. Okay, now let us try to do, well, a variation on this. Instead of drawing one such, let's draw 3 such things with 3 different colors. So let's reset. Set the width back to 3. So let's just say the speed to fastest, because I'm going to do quite a lot of circle drawing soon. And now I'm going to use what I learned about lists in the last few lectures. I'll make a list of 3 colors. Let's say red, blue. These are strings. So here you see and green. Of course, each of these are strings. So you have a list of strings. You have seen something like this before. And then what I will do is I will run a loop over this list. Now I have made a big mistake here. And the mistake simply is that I have actually overwritten the turtle's color function by my list color. Now there is a kind of mistake which actually is quite common, at least for me. And frankly, there are ways of getting around this problem, but perhaps the best thing would be to start all over again. Now this brings me to something which I should have talked to you about before, but I forgot to, which is how to get out of the Python interpreter. Well, this is something which you may have learned earlier, or you should have learned earlier if you were using Python a lot. The official way to get out of the Python interpreter is either type quit with a bracket. There's a quit function. There's another way which uses Control D. You hold down the Control key and hit D. That's equivalent to the quit function. Okay, now let's start again. Let's bring back Python 3, and of course I need to import turtle. And since I'm going to just use the inbuilt circle function, I don't have to worry about redefining the square function all over again. And I do need my list, but I'm going to call the list colors. Carefully, this is not the same name as the name of the function in the turtle module. And that's red, blue, and finally green. 3 colors. So I'm essentially going to draw the figure that I created with loops of circles, but I'm going to draw it with 3 colors, and let's see what comes out of it. So for C in colors, so I'm now running a loop over the iterable, the list colors. This has 3 pieces, so the loop will run 3 times. Of course, each time it runs, C will be red, blue and green in succession. But I'm going to have to use the color function from the turtle module to ensure that that is what the pen color is going to be. Okay, so I'm going to get color C, and then I'm going to run this loop which draws a lot of circles, like the shifted circles. Maybe I will draw it, since I'm drawing 3 such, maybe I will not make it too congested. I'm going to draw only 20 circles this time. So I draw a 100 radius circle, but I remember that after I draw each circle, I have to turn either right or left, let's say right, through an angle which is 1/20th of 360 degrees, namely 18. But now I'm going to do one more thing. Remember, our outer loop, the loop over colors, is going to run 3 times, right? Once for red, again for blue, another time for green. Now I do not want to draw the same pattern all over and over again in the same place, because if I did that, I will essentially overwrite my red pattern with the blue pattern and then with the green pattern in the end. What I will do is shift the patterns through 1/3 of the angle between individual circles. That's this 18th 1/3 through 6 degrees, and let's see what this will end up looking like. Of course, this is going to be pretty slow, and I've forgotten to, because I've forgotten to change the width and so on. Okay, let's do one thing. This is too slow, so maybe I'm going to stop this by hitting Ctrl C. Let's speed up the things. Let's also first reset. Then we will change the width back to 3 so that our familiar thick line is drawn, and we'll also change the speed to fastest. And then for C in colors, change the color to C. Then draw a pattern of 20 circles, each of radius 100, but turned around through 18 degrees. And then once each pattern is drawn, so this is complete one pattern of 20 circles. Once that's drawn, I'm going to turn further through 6 degrees so that 3 patterns don't fall on top of each other. Let's run this and see what happens. So I'm pretty sure you will agree with me that this is a pretty nice pattern to draw. Now, since the turtle module allows you to draw various kinds of things with various shapes, it's only your imagination which limits what kind of pictures you can draw. So, in this particular lecture, we have not really learned any new Python constructs. We have just used the Python constructs we already had learned before to create some nice patterns using the turtle module. In the next lecture, we will again create some more nice patterns. We will create something called the Fibonacci spiral, for example. You may want to look up what that is. But in the process, we will also learn a few more new things about various Python objects. So until then, bye.